My name's Luke Shadler. I'm doing chapter 4, syllabus 5 through 9. I don't have a clicker, so I have to walk up here. Wave features. What is a wave feature? It's the amplitude, wavelength, frequency, and speed. The crest of the wave is the top of the wave. The trough is the bottom of the wave. The wavelength is the distance between the corresponding points on the adjacent waves, which could be the crest to the crest or the trough to the trough. Like right here, these are the crests and these are the troughs. 5b, frequency. Frequency is the number of waves that pass a given point in the specific time until units. Waves/seconds is equal to 1/s is equal to, this should be 1 to the negative power of 1. That makes sense. And then hertz. Wave equations. C is equal to the speed of light, which is equal to 3.00 times 10 to the power of 8 meters per second. Wavelength and frequency are inverses of each other. So these are all the equations. So it's speed of light over wavelength and frequency. Frequency is always a V. Wavelength is this weird thing right there. And then it would be, if you're trying to find your wavelength, it would be speed of light divided by the frequency. If you're trying to find frequency, it would be speed of light over the wavelength. If you're trying to find the speed of light, it would be the wavelength times the frequency. As you can see, it's also right here. Let's do some problems. So first problem. Calculate the wavelength of a photon that has a frequency of 2.5 times 10 to the power of 12. So the first thing we do is C is equal to, and then frequency, which then you would just do, you're trying to find this, right? So it would be this is equal to C over V, which is speed of light over frequency. So you need to know the speed of light, which is 3.00 times 10 to the 8th meters per second. Over, which you have right here. So you bring that down right here, which would be 2.5 times 10 to the power of 12 meters per second. Or hertz. Sorry, hertz. And which hertz is equal to s minus 1, which is equal to meters. So then you just divide these two, which will get you to, which is equal to, this is equal to 1.2 times 10 to the negative 4. Meters. What is the frequency of a photon that has a wavelength of 1.5 to the negative 8 meters? So, the frequency, so I have this right here, right? So now we're trying to find frequency. So the frequency would be V is equal to C over the wavelength. So you would just take the 3.00 times 10 to the 8th meters s over 1.5 times 10 to negative 8. In which 1.5, or 3 divided by 1.5 is 2. So you put 2 down here. If you're trying to divide a negative from right here, it'll be a plus. So it'd be 2 times 10 to the 16th. Then and you have hertz, since it's frequency. Determine the wavelength of a photon that has a frequency of 95 megameters. So first thing you do, same thing right here, or same thing up here. It should be wavelength is equal to C over V. But megameters is equal to 1,000, or megahertz is equal to 1,000,000 hertz. So what you want to do is 95 M H Z over 1 times 10 6 H Z over megahertz. And these will cancel out. So it would be 95 times 10 to the 6th power, which would be 9.5 times 10 times 10 to the 7th.
Family number 9 to see Santa, please come to the multi.
And then you would pick the speed of light, which is 3.00 times 10 to the 8th meters per second, over 9.5 times 10 to the 7th hertz, which is equal to, if you divide all that, it's equal to 3.16 meters. That is your frequency.
Family number 11 to see
Photoelectric
Santa,
effect,
multi-purpose.
which Einstein
Family
founded,
number
pretty much.
11.
The emission of electrons when light shines on the metal. Light with enough high frequency is capable of knocking loose electrons off from a metal. Wave and particle debate. According to wave behavior, a frequency of light should knock loose electrons, but experiments showed the light had to be a specific frequency, which is particle behavior. Max Planck explained the photoelectric effect in regards to the particle behavior.